Hello everyone. Welcome to our video on organic nomenclature, or also known as naming of organic compounds. All right. So let's go ahead and get started in doing that. There we go. Okay. So when we're naming organic compounds, uh, we have to remember one thing. There's two types of naming for organic compounds. There's a systematic way of naming them, right, which is using the IUPAC system. IUPAC stands for the International Union of uh, Practicing and Applied Chemists, I believe. And so what they did was they came up with a systematic way of naming all organic compounds, right? But then oftentimes though you'll see that there are some compounds that have a common name, right? And you are expected to know the common name for some of these molecules, right? But what we're learning right now is how to systematically name all organic compounds, right? And again, that's known as IUPAC nomenclature. And the first one will, it all starts and it begins with alkanes, okay? Um, and just in a nutshell, when you're naming alkanes, the first thing you got to do is get the parent name of the molecule, and that's the longest carbon chain. Then you have to name the substituents on that carbon chain, and then you have to provide the location of those substituents in the name. Okay, so here's our first step: identify the parent chain, right? And that is the longest consecutive carbon chain. Okay, so when you're doing that, you can start from one side here, right? And you can just start counting carbons. And the one that has the longest or the most amount of carbons will be your longest carbon chain. So you can go like this, 1, 2, 3, 4. That's not that many, right? There's plenty, there's more than that. Maybe we should go 1, 2, 3, 4, 5, 6. 6 is a lot, but I think there might be a longer chain, okay? 1, 2, 3, 4, 5, 6, 7, 8. That's pretty long, right? That one's pretty long. But there might be even longer one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this chain right here, the one I'm circling right here, right? That chain right there is 9 carbons long, right? So that's going to be the longest carbon chain in that molecule. And you can see that's what they've shown as the longest carbon chain here on the right hand side, right? So uh, your parent here, right, is going to have 9 carbons. Okay, just as a preview, we call this a nonane. Okay, a nonane. So after we do that, right, we need to decide, what if there's two parent carbon chains that have the same number of carbons and they're both the highest, right? For example, here we have a carbon chain that's uh, 1, 2, 3, 4, 5, 6, 7 carbons long. And then we have one here that's 1, 2, 3, 4, 5, 6, 7. Also 7 carbons long. So how do we know which one to choose? Right? How do we know which carbon chain to choose as the parent chain? Well, in that case, if there are two carbon chains that are the same number of carbons and they're both the longest, right? You choose the carbon chain that yields you the most substituents. Here we have an ethyl group, a second ethyl group, and a methyl group, right? So that's 3 substituents, right? On this one, though, there's only 2 substituents, an ethyl group and an isopropyl group, right? So the correct one to choose as the longest carbon chain would be the one that has the most substituents, okay? So that one's the correct one. So once you've gotten that far, you've got to decide now, right? You've got to decide now how to name it, right? And for an alkane, you name it based on the number of carbons there are. So we go back to the first thing we did. Remember that had 9 carbons. That's going to be a nonane, right? As you can see right there, there's 9 carbons, and the parent is a non, and the name of the alkane is nonane, right? On this one here, it's 7, right? 7 carbons long. So that would be here, which is heptane, right? Hept and heptane. So the first 4 of these, like 1 carbon, 2 carbons, 3 carbons, and 4 carbons, are the only 4 that sound kind of different, right? One means methyl, right? right, or meth. 2 means eth or ethyl. 3 means prop or propyl. And 4 is bute or butyl, right? That's how many, those are for the first 4 number of carbons, right? 1, 2, 3, and 4 carbons. But the rest of them afterwards are pretty easy because, pent means 5, like the pentagon, right? Or hex means 6, right? Like a hexagon. Hept is 7. Oct is 8, like octopus. No 9, right? And then dec, like decade, is 10, right? So the rest of them after 4 carbons is pretty simple. So the ones that you have to remember and memorize are these first 4, okay? Methyl, ethyl, prop, and bute, right? Methyl, ethyl, propyl, and butyl, okay? There's even more after that too. It gets a little bit more complicated to remember, right? But it's still pretty simple, not like the first 4, right? 11 is undec, like undecane. 12 is dodecane. Tridecane for 13. Tetradec, right? Pentadec. Notice that it's just the penta is 5 part and the dec is the 10 part put together, right? 20 is ecos, right? And you know ecos from the shape, the icosahedron, which is a 3-dimensional shape, right? That has 20 sides on it, right? And then there's 30, which is triacont, right? And then 40 is tetracont, pentacont, and then 100 is hect, right? You'll never go up that high, but just for future reference, okay? Just for future reference. So next thing is that what if the parent chain is cyclic, right? It's not like an open carbon chain, but it's in a cycle, right? Well, that's easy. You just add the prefix cyclo to it. So here we have 3, 1, 2, 3 carbons. So just knowing that, it's a propane, right, for 3 carbons. But since it's cyclic, right, well, it's a triangle, but it's in a cycle. Well, cycle makes it sound like it's a circle, but it's all connected right there like a triangle. You call it cyclopropane. Same thing here, 1, 2, 3, 4, right? 1, 2, 3, 4. And that makes it a butane. And since it's a butane that's a cyclic butane, we call it cyclobutane. And then the last one here, whoops, didn't mean to go backwards. Let me go forward again. And the last one we have here is cyclopentane, right? Because it's 1, 2, 3, 4, 5, like the pentagon. And it's cyclo, so it's called cyclopentane, or cyclic, right? So it's called cyclopentane. All right, so let's practice some naming here, or actually let's practice naming the parent compound, okay? So, excuse me, if I do this one here, 1, 2, 3, 4, 5, 6, all right? That's 6 carbons. If I go this way, 1, 2, 3, 4, 5, the longest carbon chain is this one here, right? So that's going to be a hexane. Let's try this one now, okay? We could do 1, 2, 3, 4, 5, 6, 7. Okay, that's a lot. I mean, that might be it. Or it could be 1, 2, 3, 4, 5, 6, 7. Maybe that one is 7. Okay, okay. How about 1, 2, 3, 4, 5, 6, 7? Right? 1, 2, 3, 4, 5, 6. Can't be that. So we have a lot of 7s here, right? So already we know that there's going to be some kind of heptane, right? Because the longest carbon chain is 7 long, right? And which is the parent, right? So remember that we want to choose the one with the most substituents, okay? So if we chose this one right here, 1, 2, 3, 4, 5, 6, 7, right? It only has 2 substituents, this guy right here or this guy right here. So that's not that many substituents, right? Just 2 of them. But if I choose the one that goes straight across, 1, 2, 3, 4, 5, 6. Oops, I messed up the counting there. Let me try that again. Let me erase real quick and try that again. See, this is why you should do chemistry in pencil. Erase. Okay. 5, 6, 7. If we choose that one, that line right there, right? We have this substituent, this one, and this one. So that's 3 substituents. So that's going to be a carbon chain right there. That's going to be a carbon chain. Okay. And this one's pretty simple because it's symmetrical on both sides. So it's going to be 1, 2, and you can go around the top or the bottom. 3, 4, 5, 6, 7, 8. Right. So this is going to be an octane. But interestingly enough, it's a cyclo, right? So in fact, we would name it this way. Let me erase my numbers again. This is why it's always good to have a pencil while you're doing this. There we go, back to pen. And then you could name it like this, which is probably more accurate. 1, 2, 3, 4, 5, 6, 7. So you could say it's actually a cycloheptane. And then you have 2 substituents here, right? And they're both metals, right? So it would be 1-dimethyl cycloheptane, right? 1-dimethyl cycloheptane. Okay. This one over here would have been, we haven't gotten this far yet, but just as a preview, since we chose that this was going to be the longest carbon chain, we want the substituent, which is this guy, to have the lowest number possible. So it's going to be on carbon 3. So this one would be 3-methyl, right, hexane. Okay, 3-methyl hexane. Okay. This one's a little bit more complicated. The middle one is a little bit more complicated because, oh, di right there, because it's di 2-methyl groups. I forgot to say that. But this one's a little more complicated. We know it's already a heptane, so we can write that part down. And then when you're naming your substituents, you always do in alphabetical order, right? So we have 2 methyls and 1, 2, 3 propyl, right? So it would be, and these are both symmetrical, so you can start at either side here. So it would be 3, 5-dimethyl. I've run out of room, so I'm going to have to erase again. 3,5-dimethyl, right, hyphen 4 propyl hexane. Okay. Good stuff there. Good stuff there. I'm sure that we're going to go through this later on, but no, just as a preview. Okay. So next step is to identify the substituents in the longest carbon chain, right? And so we just did that in the previous slide, but we'll do it again here. So here's the parent: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So the parent is a decane. Okay. And then we have these substituents here. So a substituent with only 1 carbon is called a methyl, like I said in the previous slide. A substituent with 2 carbons, like here, is called an ethyl. right? With 3 carbons, it's called a propyl. Okay, those are the substituents. And then butyl is 4 carbons, and the rest of them are self-explanatory: pent, hex, heptyl, and octyl, right? So, and sorry about that. I've already answered this slide. So again, we have an ethyl up here, a propyl here, and a methyl here. So all you're really doing is that instead of ending it with an ane, right, like hexane, propane, or ethane or heptane, right, you're going to change that ane into il when it's a substituent, right? And that's why you hear me saying methyl, ethyl, propyl, and all that stuff, right? If it's a part of the carbon's parent chain, it has ane in it, right? But if it's a substituent, it ends in il, not ane. Okay. So, um, so now you can have a ring. You know, a ring can either be a parent or a chain. Oh, sorry, a parent chain or a substituent, depending on the number of carbons, right? And so here we choose that the largest, ring here will be, I mean, not the largest ring, but the ring here will be a parent. And the reason why is because it can either be the substituent or the parent, right? But if you had it over here, this only has 1, 2, 3 carbons on it, right? But this one here, the cyclohexane here, has 1, 2, 3, 4, 5, 6 carbons on it, right? So you choose whether or not you're a parent or a substituent by the number of carbons you have, right? And so in this case, the parent is the cyclohexane because it has more carbons than the propyl group, right? So that's why the parent name then is cyclohexane, right? And I don't know why I marked that out. I can't even read it now. Sorry about that. There we go. The parent then is cyclohexane, and you just put the propyl in front of it, propyl cyclohexane, right? Here, when you're trying to choose, in the second one, you're trying to choose which one it is, right? Which one's the substituent and which one's the parent. The carbon chain has 4 carbons, and the cyclo only has 3 carbons. So here, the butane becomes the parent, and the cyclo becomes a substituent, right? And if we name it 1, 2, or number it 1, 2, 3, and 4, because we always want to have the substituent with the lowest number, we get butane, right, from the 4 carbons in that carbon chain. And then we get the 1 from the substituent being on the number 1 carbon, right? And that substituent is a cyclopropyl group, right? It's a 3 carbon cyclic molecule, cyclic, 3 carbon cyclic, right? So that's cyclopropane. Oops, went too far, sorry. So now we also have this other issue too. What if the substituent has complex branches, right? So again, our parent chain is this one right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11. I've already forgotten what 11 is now. I think it's undecane. So the parent is undecane. I'll write that again, undecane, all right? But then we have a substituent here that is 4 carbons long, which makes it a butyl group, right? But then on the second carbon right here, there's also another substituent that's a methyl group right here, right? This guy right here. So you put it all together as the substituent name, right? So we have our parent our parent chain, right, for the substituent, which is a butyl, okay? And then on the second carbon, there's a methyl. So you just put 2-methyl butyl, right? And now that's the name of your substituent, right? That's the name of your substituent. Good stuff, good stuff. So we also have some other pretty common names for we have some common names for some other substituents too, right? Here we have, as you've seen already before, a 3-carbon chain is called a propyl. But when you have a 3-carbon chain that's attached by the center, by the by the second carbon, that's called an isopropyl. That's the same thing as you would see in isopropyl alcohol, right? Here's some more common names for some substituents. Of course, a 4-carbon chain as a substituent is called a butyl. But when you have it when you have it so that the parent is connected to the second carbon of the butyl, it's called a sec butyl, right? It's called a sec butyl. This one here is called an isobutyl because it almost looks like an iso uh, propyl, right? Or an right there, an isopropyl. It almost looks like that, right? But it does have an extra carb on it, right? 1, 2, 3, 4. And so that's why it's an isobutyl. Okay. And then the last one is called the tert butyl. And the tert butyl has 3 methyl groups just all by itself right here. 1, 2, 3, with a center carbon right there holding them all together, right? And that's a tert butyl. You can think of it as being like tertiary or 3, and that's 3 methyl groups, right? Those are some common names that you need to memorize. Okay, so let's try this out now, right? Let's assemble the IUPAC name. We have here a 1, 2, 3, 4, 5 carbon chain, right? And this is also a 5-carbon chain. We have one where we have this methyl group as a substituent here. So the name is 2-methyl, right? And then pentane for the 5-carbon chain, parent chain. Here though, right, the methyl group is attached at the 3rd carbon. So that's why we call it 3-methylpentane. Okay? It's 3-methylpentane. Okay? And again, generally you want to have it so that the substituent is numbered the lowest possible, right? So here 2 is the lowest number possible for that substituent methyl right there. But when you have it 3 right in the middle, it really doesn't matter. You could number it from this side as 1, 2, 3, 4, 1, 2, 3, 4, 5, or you could number it from this side as 1, 2, 3, 4, 5, and it would still be on the 3rd carbon, right? So it doesn't matter when it's symmetrical. All right, and so I just said this in the last slide, right? If one substituent is present, the number of the parent change so that the substituent has the lowest possible number, right? So it's definitely not going to be this one because here your substituent is on the 6th carbon, right? So it can't be that one. It's going to be this one where the substituent is on the 2nd carbon, and this is a heptane. The substituent is on the 2nd carbon, so which is a methyl group. So this one's going to be 2-methyl heptane. Okay, 2-methyl heptane, right? And it sounds better too because if you had it there, it'd be 6-methyl heptane. Well, that's not as cool, right? It's definitely going to be 2-methyl heptane. It sounds better. Okay. So when you've got more than one substituent present, right, you still want the parent chain to give the first substituent the lowest number possible. Okay. So let's look at the wrong one real quick here. Or we still have a heptane going on, right? 7 carbons long, a heptane. Over here, the first set of substituents has number 3, right? So that's 3, 3, okay, for both those methyls, and the last methyl is on a 6. But here on the correct one, we go 1, 2, 3, 4, 5, 6, 7, right? The first substituent is on 2, and then the other 2 substituents, the 2 methyl groups, are on 5, right? 2, 5, 5. So the lowest one here, right, the lowest number of carbon is going to be 2, which means this is the correct one, right? That's the correct one, okay? So we can go ahead and name this here. I mean, it doesn't say to, but we can go ahead and name this, right? I will start out with the parent chain first, heptane, right? And then usually we name our substituents in alphabetical order, but these are all 3 methyls, right? So the answer would be, or the name would be 2, 5, 5, 2, 5, 5, no, not thigh. Let me write that again. Erase. it would be 2 for that carbon for that methyl there, 5 for this one methyl here, and another 5 for this methyl here, and it would be trimethyl heptane, right? Trimethyl heptane. Okay. The next one, okay. If there's a tie, right, then you want the parent chain so that the second substituent gets the lowest number, right? So in this case, we have a methyl group at the second carbon and at the sixth carbon on both, and so that would be a tie, right? That would definitely be a tie because you don't know which one's going to be which. They're both on like the second carbon. So now you go to the next one in line, which is the third carbon, right? And that's sorry, go to you go to the second carbon, right? Because the first carbons are the same on both ends, right? On the correct one, it's still 6 and 2, and then the incorrect one, it's 2 and 6. So there's symmetrical that way. So there's really no that's a tie, right? So we have to go to the second carbon, and then or the second substituent. And here, the second substituent is this guy here, this methyl here, and this methyl here, right? And so we want the second substituent to have the lowest number, so it's going to be 3, right? Not 5, okay? Because 3 is lower than 5, and that's why we name it this way, right? 1, 2, 3, 4, 5, 6, 7. And so we can then name it, again, this is a heptane, so I'll always write the heptane out first, okay? And this time it's going to be 2, 3, and 6. Oops, I did it too close to the thing again because I'm running out of space. I gotta erase that. That's why it's good to have an eraser. Trimethyl heptane. All right, trimethyl heptane. Good stuff. Good stuff. So now, all right, if there's a tiebreaker, oh sorry, if there's no other tiebreaker, right, like you can't do the tiebreaker based on what number carbon is at, then you assign the lowest number alphabetically. And I've said that before in class, right? So here we have we have a pentane, right? One, 2, 3, 4, 5, right? And on one of them, the bromine is number 1, and the chlorine is on the fifth carbon. And on the other one, the chlorine is on the first carbon, and the bromine is on the fifth carbon, right? So we're doing this alphabetically. Bromine is before chlorine in the alphabet, I believe, right? So bromo beats chloro, right? Bromo beats chloro. So here you would name it as 1 bromo, right? 5 chloro, right? I forget what we're doing. Oh, heptane. No, pentane, because it's 5 carbons long, right? All right. What if it's a cycloalkane, right? So this time, right, the same rule applies for the cycloalkanes. This is going to be a cyclohexane right here. All right. 1, 2, 3, 4, 5, 6. Okay. And this time, again, you want the one with the most substituents to have the lowest number, right? And so the one with the most substituents is the carbon on this side, right here, those two methyls right there, right? If you name it over there, and then you have 3 as the lowest number of substituents, right? Or the highest number of substituents. But over here you have 1, which is lower than 3, right? It's lower than 3. And so that's going to be the one with the highest number of substituents on it, right? So that's when we count it 1, 2, 3, 4, 5, 6, because the more substituents are on with carbon number 1 there, right? Instead of over here, okay? Instead of over here. So quite easy to name this one as well. It's going to be 1, 1, 3, oops, I forgot the tri part. Trimethyl hexane. right? Trimethylhexane. Can't even read that. Let me write that again. Trimethylhexane. Okay. So let's complete the name now. I've been completing the name for you, right? I've been completing the name for you, but the last step is to put in put the number and the name of each substituent before the parent name in alphabetical order, right? And prefixes that you can use, right, for identical substituents are di, tri, tetra, and penta, right? Two, two of the same, three of the same, four of the same, five of the same, etc. Right? If multiple substituents are identical. But when you're alphabetizing it, you don't have to worry so much about those prefixes that denote what the number is, how many there is. Okay. So here's a summary. Okay. The first thing you do is you identify the parent chain. Okay, and that's the longest chain of carbons. And the next thing you do is you identify the name and the substituents of that of that chain of carbons, right? After that, you number the parent chain, and assign the lowest number to the lowest. Uh, sorry, you assign the numbers, you number the carbons, and you assign it so that the substituent gets the lowest number, right? And then you list the numbered substituents before the parent name in alphabetical order, which we've been doing, but that's just a summary of the list of what you need to do. So here's a big one right here. Looking at this molecule, right, the first thing you need to do is you have to number the longest carbon chain. But the thing about it, though, is that in this one, the longest carbon chain uh, is the cyclohexane, right? I mean, you could have the longest carbon chain be like starting from up here, 1, 2, 3, 4, 5, 6, 7, like that. But then you have all these other things that you have to name and it makes it super complicated, right? And then also remember that one rule we had a few slides ago, where you can either have the cyclo part be the substituent or the cyclo part be the parent chain, and and then that's based on the number of carbons, right? And so when you circle this part here, which is the cyclo part, it's got more carbons, right? 6 of them, so it's got more carbons than every other thing there, right? So this guy right here only has 4 carbons. This guy over here only has 2. This guy only has 1, and this guy only has 1, right? And so the parent here is going to be the cyclo, okay? And the rest of those guys, this tert butyl right here, this ethyl right here, and then these 2 methyls right there are going to be substituents, right? So let's go through this. I erased all my marks so I can actually name this for you. Go through the process of naming this guy for you real quick. So our parent here is going to be, we'll start numbering it here, right? 1, 2, 3, 4, 5, 6, okay? And the reason why we're doing it that way is because we're doing it alphabetically. Butyl, right? We do it alphabetically. Butyl is before ethyl, and ethyl is before the 2 methyls, right? So number 1 will be where the butyl is, right? And then number 2 will be where the ethyl is. This is the ethyl right here, right? This is the butyl right here, tert butyl to be exact. Remember, we don't have to worry about these prefixes right here when we're doing the alphabetical part. That's just telling you how many carbons there are, okay? And then the 2 methyls are down here and they'll be at 4. We'll put it all together, right? I always start out with, and it's already down here for you, right? But I'll just go through each one, right? I always start out by saying what the name of the parent is, which is here, it's cyclohexane, right? And then I'll go all the way back onto the left right here and start out with 1 tert butyl. It's because it's alphabetical. And so here's on carbon 1, and the tert butyl is right there, right? Next after that is the 2 ethyl, right? The 2 ethyl, which is right here because it's on carbon 2, and here's the ethyl group. And then the 4,4 dimethyl, because here on the 4th carbon there are 2 methyl groups, and that's dimethyl. And then I've already put down the cyclohexane, right? So it's as easy as that. So naming alkenes is similar, right? It's similar to naming alkanes. The only difference really is that instead of having alkane with and then an ane, alkenes are double bonds, and so we end that with ene, right? So here we have pentane, but if this pentane has a double bond at the end of it, like it does right there, we change the name to pentene, right? And the slight modification is that when you name an alkene, the alkene has to be in the parent chain, okay? Or the double bond has to be in the parent chain. So here we have octane under the alkane rules, right? Which is 1, 2, 3, 4, 5, 6, 7, 8. And normally under the alkane rules, that's perfectly fine. But since we have an alkene here on this substituent right there, right? This alkene right here, or this double bond right here on that substituent, you're gonna have to number it so it includes the alkene, right? And then also the alkene needs to be closest to the end too. So we'll actually start over here. 1, 2, 3, 4, 5, 6, 7, right? And so that's why the parent is 7 here, right? Or heptene, okay? And then, just like I said just a few seconds ago, right? When you're numbering these things, when you're numbering these alkenes, you want the alkene or the double bond to be closest to the end, right? Or closest to number 1. And so that's why you start it here with 1, 2, 3, 4, 5, 6, 7, right? For that heptene there, and you don't do it on this side because if you do it on this side and you start the one over there on the right hand side, you need the alkene to be starting at carbon 5, which it's not happy with that. It needs to be the naming convention or the nomenclature convention has it so that the alkenes or substituents or whatever will have the lowest number, right? And alkenes actually take precedent here, and so that's why it needs to be at number 2, right? It needs to be at number 2 and not number 6, okay? So we can actually go ahead and name this here. We have a methyl here, right, on 6, and we have a methyl here and a methyl here on 5. So we can put it all together now, and we can name it. And I tried to name it before, and I forgot the 2, but for where the double bond is. But don't forget to put in the 2 for where the double bond is for the heptene, right? So here's the molecule we had in the last uh, slide, right? And it is in fact, like I said, 5,5,6 trimethyl, right? You can either do 2 heptene, but some people say 5,5,6 trimethyl hep2ene. I definitely prefer the top one, right? I definitely prefer the top one, but both are correct. Both are definitely correct, right? And then we also have uh, alkenes where you have substituents that are either on the same side of the alkene or the double bond or on different sides of the double bond, right? Okay. And whenever they're on the same side of the double bond, that would be called a cis butane. Butene, cis butene. Okay. That would be called a cis butene. And it's 2 because the double bond begins at the second carbon. But if they're on opposite sides of the double bond, that's called a trans butene, right? Transbutene, okay? Good stuff, good stuff. So just remember, if the substituents are on the same side of the double bond in an alkene, it's cis. If they're on the opposite side, they're trans, right, on an alkene. All right, so let's talk about naming alcohols now, right? Remember when we have, you know, when we had the alkane, we ended it with ane with an E, right? Ane, E, for this 5 carbon chain here, pentane. So naming alcohols is very similar to that, except for instead of ending it with ane, we end it with all. So now it's, we still have 5 carbons, 1, 2, 3, 4, 5, but now this carbon here is connected to an alcohol or hydroxyl group. And so that's why we call it pentanol, right? Pentanol. So again, just like the alkenes, right? You have to, when you're numbering the parent chain, you have to number it so that the alcohol is included in that chain. So again, we go 1, 2, 3, 4, 5, 6 right there, right? So the alcohol is attached right there and it's a part of the chain. And so we know then that is a hexanol, right? Because that's the parent chain. And then this right here is just a substituent, right? That little propyl group is just a substituent, okay? If it was just a regular old octane, right, or pentane, oh sorry, alkane, right, then you would just go straight across like you normally would, and you would have 8 carbons, right? And that's why it'd be all called octane. But since you have a substituent alcohol there, you've got to include the alcohol in the parent chain, just like you do with the alkenes, right? So that can change the parent name. Okay, so then again, just like the other ones, just like the other substituents, you have to assign the locant, right? So that the alcohol is the lowest number, right? The OH is the lowest number, just like we did before with alkenes and all the other substituents. Okay, so here we can name, we can either go 1, 2, 3, 4, 5, 6, 7, where the alcohol is 2, or we can be over here where it's a 1, 2, 3, 4, 5, 6, 7, and the alcohol is 6, right? But we want the alcohol to have the lowest number. Okay, we want the alcohol to have the lowest number, so the alcohol with the number 2 is the one that's correct. Okay. Okay, so just like in the alkenes, you can put a number where the locant of the alcohol is, right, just before the ol or in front of the name, right? So here the alcohol is on carbon 3, right? So it's either going to be 3-pentanol or pentan 3-ol, right? And it just doesn't sound cool. So again, I prefer that one right there, where the number with that gives you the location of the alcohol is in front of the parent name. Okay, so we do have cyclic alcohols too, right? So if we have a cyclic alcohol here, again, the parent here is going to be uh, the cyclopentane, right? But it's got an alcohol attached to it, and that's why it's called pentanol, right? And of course, since it's a cyclic and there's only one thing attached to it, you could put 1 there, right? And you can say that the alcohol's on 1. But if there's no number there at all, you always assume it's 1 anyway, right? It's on the first carbon anyway, because you want the carbon to have you want the alcohol to be on the carbon that has the lowest number, right? So here, so here we have cyclopentanol again, right? Because we have a cyclopentane, right? And it's attached to an alcohol, so that's already a cyclopentanol as your I lost my train of thought, as your parent group, right? Your parent name, and it's already on number 1, so of course you don't have to put a 1 in front of the cyclopentanol, right? But you do have 2 substituents here, and the 2 substituents are on carbon 3, right? Because you want the substituents to be on the lowest carbons, right? So it's 2 methyl groups on carbon 3, so that's 3,3-dimethyl cyclopentanol. Okay. Now this one has an R on it, right? And the R is because there's this wedge, this dashed wedge right here, you know, that's attaching the hydroxyl or the alcohol to the cyclopentanol or the cyclopentane at that carbon, right? And so whenever it's a dashed wedge like that, right, something like that, what that means is that 3-dimensionally the alcohol is going into the paper, right? But if the alcohol is attached to the cyclopentane with a solid wedge, then it means it's coming out at you, right? Out of the paper into you, okay? And when you do that, right, when you do that, you can actually assign that since these are 2 different, things right here, you can assign it to be either R or S, right? R or S. The thing about it, though, is that you don't want to, I'm not going to go into it's actually called the uh, uh, Conn-Ingold rules for naming, right? and for stereochemistry, right? And so you don't actually need to know that for any test or an exam. I'm not going to test you on that, so don't worry so much about the R and S. Just worry about the names, okay? So some common names for some alcohols here. Again, if we have like a 3 carbons with the alcohol attached to the middle carbon, that's isopropyl alcohol, right? Because so this little shape right here, this shape that you see right here, is always going to be known as an isopropyl, right? And then here we have a tert butyl, right? Again, tert butyl means 3, right? But the butyls, right? Butyl means 3, so 3 methyls, 1, 2, 3. But then also butyl because there are 4 carbons. So this is tert butyl alcohol. And so this last one here is called benzyl alcohol because this part right here is called a benzene ring, right? But then if you add on this extra carbon right here, it's called a benzol. And so now you have an alcohol attached to the benzol. It's called a benzyl alcohol. Okay. So of course we also have phenols, right? Or which are basically just alcohols attached to a benzene ring directly, right? And when you have that, you call it a phenol. Okay. When you have an alcohol directly connected to a benzene ring. So here, right, we're going to name it so that the uh, the alcohol, of course, is at the 1 for the phenol, and then 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6, right? So, and you always name phenols with the phenol name, of course. There's a nitro right there at the 2 position, and then there's a chloro at the 4 position. Okay, chloro at the 4 position. And you'll be asking yourself, how come we're putting the chloro in front of the nitro? Well, because the chloro is alphabetically before nitro, right? But why do we have the nitro at 2, right? When we should maybe have the chloro at a lower number than nitro because alphabetical. Because, well, if you were to name it the other way, right, it would make it so that the chloro here was still 4, but now the nitro is at 6, right? And so again, you want your substitutes or your substituents to always have the lowest numbers, right? And 2, 4 is lower than 4, 6, right? Then we have ethers. Ethers are pretty simple, actually, right? Is a the ether is the functional group where you have an oxygen in the middle of something, right? In the middle of 2 R groups, right? Remember, I used to say in class, and I still do, that R means the rest of the molecule, and so if you have an oxygen between 2 rest of the molecule, that's called an ether, right? And here you just name the substituents alphabetically, right? Name the substituents alphabetically, and then put ether at the end. So here we have ethyl, methyl, ether, right? Here we have, again, tert is a prefix telling you how many there is. So you don't really have to worry about that in the alphabetical thing, but you do, the alphabet part starts with butyl. So butyl for these right here, and then methyl for this right here, ether, right? That's simple, okay? All right, so now let's talk about naming aldehydes, right? So again, very similar to naming alkanes, but just like the alcohols and the thiols and all the others, the other kinds of functional groups that we can have, alkenes, right? Instead of having an E at the end, like we would have with butane, if you have an uh, if you have uh, uh, an aldehyde, you end it with al. So here we have butanal, right? Both have 4 carbons, 1, 2, 3, 4, 1, 2, 3, 4, right? But you have an aldehyde at the end, right there. You have an aldehyde at the end. So that's why it's going to be butanal now, right? And again, if we had a normal old, 8 carbon chain here, it would be called octane with nothing attached to it. But if you have a aldehyde attached to it, you're going to have to use the aldehyde inside the parent chain, right? And so we number it from here: 1, 2, 3, 4, 5, 6, right? So since there's only 6 there, it's not no longer an octane. It's going to hex now. It's going to be a hex for the parent. And then we always end it in al for aldehyde. So hexanal, right? Hexanal. And again, we want our substituents, right, to have the lowest number. That's why we put the the 1 on that carbon right there, where the aldehyde actually starts. Okay? I just said this in my last sentence. I said this: the aldehyde carbon is always assigned number 1, right? So here we can either have it over here as number 7, right, in this molecule, or number 1. But it's correct to always have the aldehyde as number 1, right? And the rest of these can just be substituents that are a part of the hexanal, or actually this would be a heptanal name. Okay. Then we have the ketones, same thing as the aldehydes, except instead of having E like butane, right, we'll have one like butone, right, butanone, right? And so it's the same thing as it is with aldehydes. You just got to change the E to into an one, right? In here, when we do this, we want the carbon-oxygen bond, or the carbon-oxygen part of the ketone, to be given the lowest number when we name it, right? And so or when we number it. So here, 1, 2, 3, the carbonyl. This actually has another word for this. Is called a carbonyl. Okay. So here the carbonyl is at position 3, right? But if you were to number the other way, starting with 1 on this side, then it would be at like position 5. And we don't want that. We want the ketone, or the carbonyl, to be at position 3, right? And so since it's position 3, we can call this 3-heptanone, right? Again, some people like to say 3-heptan 3-one, or heptan 3-one, which is, it doesn't flow very well to me. So I'm definitely a fan of the first way of saying it, right? And then I think this is the last one here, right? We have naming of carboxylic acids, right? So just like the aldehydes and the and the uh, uh, ketones and the alcohols, all we do is we change the ane part into something else. And here in this case, we name we give all carboxylic acids the ending of oic, right? So instead of having butane here, right? If you have a carboxylic acid, by the way, a carboxylic acid is a carbonyl group, right? This carbonyl group here. I don't know why I messed that up. Let me erase that real quick here. Always mess up the last one, you know? There we go. So instead of butane, right, we have butanoic acid for carboxylic acids. And carboxylic acids, by the way, if you didn't already know, but you should know because in the previous lecture, is an R group attached to a carbonyl with the alcohol, right? So this part right here is called the carboxylic acid, right? And so you have that attached to some kind of alkane, like a butane. It becomes butanoic acid, right? And again, uh, um, I lost my train of thought. What was I going to say? Oh, again, just like the aldehydes, you want the carboxylic acid to be named with the carbonyl being first, right? So that's 1, 2, 3, 4, 5, right? And so it's a pentane with a carboxylic acid. That's why it's a pentanoic acid, right? And then at the 4th carbon, there are 2 methyl groups. So that's why it's 2,4,4-dimethyl, right? And the last thing is the 5-hydroxy, which is that alcohol right there, right? So again, carboxylic acid moiety is always assigned the locant position of 1, right? And that actually ends my crash course in organic naming. If you have any questions, let me know, and make sure you go through and listen to the previous lectures on functional groups and on the introduction to organic chemistry. Thank you.